Hi everyone, and welcome to this series of solving practice problems. And this series will be about numerical derivative. So we'll start with the first question. And the first question says here that we are given x value and g of x, and we want to find the first derivative and the second derivative at point 2 using the FDD, the forward divided difference, the back divided difference, the central divided difference for the first derivative. And the given formula in the notes, I will put a link for that for the second derivative. So there is a formula we used in the notes, okay? And find the second derivative at delta x equal to 1 and equal to 2. So the first, we will use this discrete data, and we will try basically to find the derivative using the different techniques. After that, we will represent the function as a second, third, and fourth order polynomial using Newton divided difference. So this is from the interpolation. And then we will find the derivatives. But now with this one, we will change the delta x. We will use a different delta x. And the delta x will be actually equal to 0.1. Okay, so let's start. Now, this is the formula for the forward divided difference. Okay, so basically it is equal to the function at x plus delta x minus the function itself over delta x. Okay, so let's do it in the table. So at delta x equal to 1. Now we want to find what? We want to find g at 2. So x, basically this is equal to 2. And delta x is equal to, first is equal to 1. So we want to find basically the derivative as g of 2 plus 1 minus g at 2 divided by delta x, which is basically is equal to 1. Now, g2 plus 1 is g at 3. Okay, so it will be 2. So this will be 2 minus g at 2, which is equal to 3 divided by 1, and this will give me minus 1. Okay, now when we find the derivative at delta x equal to 2, now your delta x is equal to, instead of 1, it becomes equal to 2. So this is equal to basically g of 2 plus 2 minus g of 2 divided by basically 2. Now, g2 plus 2 means g at 4, which is basically is equal to 3, minus g at 2, which is 3, divided by 2, and this will give me 0. Okay, so this is how we can find the derivative using directly the discrete data. Now let's move to the second approach, which is the BDDD, or the backward divided difference. Now in the backward divided difference, basically we will have here this is the formula that we can see, and this is g prime of x. So we will just come here and start to substitute. Okay, now we have the data here as well. So g prime of x would equal to g at 2 minus g at 2 minus 1, which is g1, divided by delta x, which is equal to 1. So this will give me 3, which is g at 2, minus 5, divided by 1, and this will give me minus 2. Now, with delta x is equal to, basically equal to 2, it will be your g prime of x will equal to g of basically 2 minus g of 2 minus 2, or g of 0, divided by 2. And when you substitute, you will find this is equal to minus 2.5. Move forward This is the CDD, which is basically the average between FDD and BDD, actually. Okay, so let's move on here. So this is the formula. So your G prime of X, which is 2 here, is equal to G of 2 plus 1, which is 3, minus G of 2 minus 1, which is 1, divided by 2 times 1. And when you substitute, you will find this is equal to minus 1.5 for delta X equal to 2. So it will be G of basically your X is 2 plus 2. So it is 4 minus G of 2 minus 2, which is basically 0, divided by 2. And when you substitute the values from the table, you will get this is equal to minus 1.225. Now, let's move to the second derivative. And this is the formula that I referred to the question. As I said, this is basically the use of this formula or the derivation of this formula has been explained well in the notes, and I will keep, as I mentioned, the link for that. Now here, the G double prime. Now delta X is equal to 1. X basically is equal to 2. So this is 2 plus 1, or so your G double prime, or this is G double prime, is equal to G at 3 minus 2 G at 2 plus G at 2 minus 1, or 1, divided by 1 square. And this will give me an answer that is equal to 1. Here we'll do delta X equal to 2. So everything is exactly the same. So here we have G at 4 minus 2 G at 2 plus G at 0 divided by 2 square, and this will give me 1.225. So this is how we can find the first derivative using any of the available techniques, and as well as how we can find our basically our second derivative as well. Now, another approach to find the derivative for discrete point is to find a continuous function using the interpolation. So we can link the interpolation with the derivative in this part. Okay, so we will start basically here. So we will use a second order function. So we have here X. Okay, now we want to find 2. So we'll have 1, 2, and 3. This is your X, and you will have G of X. G of X is basically 5 and 3 and 2. So as we have learned before, 3 minus 5 over 2 minus 1. So this will be 3 minus 5 over 2 minus 1, and this will give me minus 2. 2 minus 3 over 3 minus 2, this will give me, so 2 minus 3 over 3 minus 2, and this will give me minus 1. And then finally, minus 1 minus 2 divided by 3 minus 1. So here basically minus 1, this will be 1 over 2, so this will give me 0.5. So this is basically your B0, B1, and B2. So your G of X will equal to B0 plus P1 X minus X0 plus B2 X minus X0 times X minus X1. So here B0 is nothing but equal to 5 minus 2x minus x0, which is 1, plus b2, which is 0.5, times x minus x0, which is 1, times x minus x1, which is basically equal to x minus 2. So this is the function. And now we want to find basically with delta x equal 2.1, we want to find the forward divided difference. So we will use exactly the same formula that we have, that this will be g of x plus delta x minus g of x divided by delta x. So now we know everything. We know this is your g of x. We have the continuous function. Okay. Now, so this will becomes equal to g of 2 plus 0.1 minus g of 2 divided by delta x, which is 0.1. Now come and substitute the value here and find the derivative, which is give you minus 1.4045. Now, when you go to the backward divided difference, it's exactly it's the same function that we used before, which is basically g of x minus g of x minus delta x divided by delta x. So now we have everything. So this is equal to g at 2 minus g at 2 minus 0.1, which is 1.9 divided by delta x, which is 0.1. And this will give you a value of minus 1.55. And finally, for the CDD method, it will be basically g at 2.1 minus g at 1.9 divided by 0.2, and this will give you minus 1.5. And you can see here, this is basically the average of these two values. Finally, we will find the second derivative, and the function for the second derivative is basically equal to g of x plus delta x minus 2g of x plus g of x minus delta x divided by delta x squared. So this will be equal to g of x plus delta x 2.1 minus 2g of 2 plus g of 1.9 divided by 0.1 square. Then once we found all the values from the functions that we found here, you will find that the second derivative is basically equal to 1. Now we move forward and we find the third order polynomial. So basically we will have here third order polynomial. We will have our x's now will include the 0. So we have 0, 1, 2, 3. And then we have g of x, which is basically 8, 5, 3, and 2. Now we will move on. 5 minus 8 divided by 1 minus 0. So this is minus 3, minus 2, minus 1. Move on here. So this will give you 0.5, 0.5. And finally, this will be equal to 0. Okay. So from this, you can find that your g of x is basically equal to, now this is your B0, B1, B2, and this is basically nothing but your B3. And you can see here for the third order, the coefficient with the x cube is equal to 0. So this is equal to B0 plus B1 x minus x0 plus B2 x minus x0 x minus x1 plus B3 x minus x0 x minus x1 x minus x2. Now, because this is equal to 0, so all of this goes to 0. So this now is equal to 8 minus 3 x minus 0 plus B2, which is 0.5 x minus 0 times x minus 1. And this is basically your derivative. So for the forward divided difference is equal to g at 2.1 minus g of 2 divided by 0.1, and this will give me minus 1.45. And almost we are getting, not almost, we are actually getting the same as this results. This is basically, it is both are the same function. So we are getting exactly the same. So we'll get here minus 1.55, and here we'll get minus 1.5. And for your second derivative, you will get also 1, because these two functions, this function and the previous one, are basically exactly the same, because the component of the x cube has been cancelled out. Now we go for the fourth order polynomial, okay? And for this, you can basically, now we will have 0, 1, 2, 3, and 4. Your g of x is 8, 5, 3, 2, and 3. And now we will basically move on. So basically we will have here minus 3, minus 2, minus 1, and 1. And again, we'll be moving forward 0.5, 0.5, and 1. And then here you will have 0, 0.167, and finally we'll have 0.042. So this is your B0, B1, B2, B3, and B4. So here we will have basically a fourth order polynomial. So because this part is not equal to, basically is not equal to 0, and your g of x will be equal to 8 minus 3x minus 0 plus 0.5x minus 0 times x minus 1 plus, of course, 0 times the rest, so there's no need to add that, plus 0.042 x minus 0, x minus 1, x minus 2, and finally x minus 3. So with this is your basically your polynomial, and now you can go and calculate everything here. So your FDD equal to minus 1.54. I don't need to calculate now everything because it's sort of repetition. The PDD is minus 1.629. The CDD is minus 1.5845. Again, the CDD is something in the middle. And finally, your second derivative will be equal to g of 2.1 minus 2g of 2 plus g of 1.9 divided by 0.1 square, and we do the calculation, this is equal to 0.889. Okay, so that is a very good question that summarizes how to deal with discrete data from both perspectives, the perspective of directly from the discrete data, but there we have a limitation on delta x. We can only use delta x which is equal to 1 here, because this is the minimum that I can get. I can't go lower than this. I can go increase delta x as we have seen to 2, but I cannot lower it than 1, so I will not get a very good results. But now once I can find the polynomial third, fourth, and fifth, then we can choose any delta x that we want. Now, let's go to question number 2 here. It says here, consider the function. You are giving here a continuous function, x squared sine 1 over x. Obtain the estimate for f first derivative at 1.5 using the FDD, the BDD, and the CDD methods. We start with 0.1. And now here we reduce delta x by half until our true relative error is less than 0.01%. Now, when we are given a continuous function, I can easily find basically the actual function. So here, your f prime of x is equal to 2x sine 1 over x minus cosine 1 over x, of course, multiplying by 1 over x squared times x squared, they will cancel. So this is your f prime. So this will lead to the fact that f prime of 1.5 is equal to 1.069222. So now I know the exact value, the actual value of 1.5, then I can find basically the true error. So we'll start with the FDD method. So we'll start with x equal to 0.1. Now, when you do the FDD method, we'll start, okay, so this basically f of x is 1.5 minus, sorry, plus 0.1 minus f of 1.5 divided by the delta x, which is 0.1, and this will give me 1.065. Okay, now we will find the error, which is the absolute value of 1.069222 minus 1.065 divided by 1.069222 times 100, and this will give you 0.395%. Still far away from this, so we'll go to the second level, which is 0.05. Now we will find f. Now we will add 0.05, so 1.55 minus f of 1.5 divided by 0.05. Now, how to find f 1.55? Simple, you go and substitute it in your function here. But you have to notice that it's very important that x here has to be in radian. This is very, very important. So now at 0.05, so this will be equal to 1.068. So again, I will compare this with the true error. So it will be 1.069222 minus 1.068 divided 1.06922, and this will give me an error percentage of basically equal to 0.114%. So we'll keep doing this, okay? We keep on, so we'll go for 0.025, 0.0125 until we finally reach to the value where we reach to the error, which is basically when we reach to the value of 0.01565, and from this you will find that your derivative is equal to 1.06912, and the error will be equal to 0.00954%, and at this delta x we reach to the required error. Okay, so we just keep on doing this until you reach to this. Now, if you use the backward, now we know that the forward and the backward converge at the same rate, and we'll try to do that. You will find that is basically matching. So at delta x equal to 0.1, your function will be basically f of 1.5 minus f of 1.4 divided by 0.1, and you will get that the derivative here is basically equal to 1.073, and the error is 0.353%. So again, you keep on 0.05 going until you reach exactly the same point, which is 0.01565. You will get that the derivative is basically equal to 1.069312, and the error will be equal to 0.0084%. So only when delta x reach that level, we reach to the required error. Now, on the other hand, when we use the central divided difference, its conversion is much faster than the others. And basically here at delta x equal to 0.1, this is equal to f of basically 1.6 minus f of 1.4 divided by 0.2, and this will give me a derivative equal to 1.069, and the percentage error is 0.021%. So you can see here we reach to very high value, close to the actual one very fast at 0.05. basically here you will find that the derivative is 1.06929 and the percentage error is 0.006%. So only after basically two iterations, we managed to get the required accuracy. And this is why the central divided difference, and we have shown that it is converged at a rate much faster than the FDD and basically the BDD. Now here, this is the last question. We have an f of x equal to x times e to the power of x sine of x. We want to find the first derivative at x equal to 2 using the central divided difference only. We'll start with 0.1 and we reduce by half, and we want to have the true error to be less than 0.05%. So basically your f prime of x is equal to e to the power of x sine x plus x e to the power of x sine of x and plus x e of x cosine of x. So this will lead to that your f prime of 2, because this is where we want to find the derivative, is equal to 14.00668. Okay, now we use the CDD for delta x equal to 0.1. Your f prime is basically equal to 2 plus 0.1 minus 2, minus f of x, which is 2 minus 0.1 divided by 2 delta x, which is basically 0.2. So this is 2.1, 1.9, and we substitute in the function here. Again, x has to be in radian, something you have to be careful with. So we'll get 13.9105. So the percentage error will equal to absolute value of 14.00668 minus 13.9105 divided by 14.00668 times 100, and this will give me 0.687%, still higher than the required accuracy. Then we'll go for delta x equal to 0.05. Okay, and from this we will find basically your function f at 2 plus 0.05 minus the function at 2 minus 0.05 divided by 2 times 0.05, and when we substitute the values, we'll get this is equal to 13.982, and from this you can find that your error is equal to 0.176%. Still we did not reach, and finally at delta x is equal to 0.025, you will get that your derivative using the CDD method is equal to 14, and from this your error will be equal to 0.0477%, and this is less than the required accuracy, and basically we will stop at this level.